Okay, Gia will upload it down. I guess you'll see it. Oh, maybe it's not.
Three, two, three, six. So 4, 5, 6, 5 S2 and 6. 4.
So if we that'd be 3s2, 6, 4s2, and then 3
his cousin and his sister.
3d10. 3d10, which is 21 and 30, and
And
then
then
4p6,
and then
and
two
then
5s.
5s, and then like 4. How do you go from 3 to 4?
I down.
You go fries and then you go six.
Until you're done. You find the element.
The S is just.
It's asking for arsenic, so find arsenic and that's where you stop. Yeah.
It's gonna be 3.
For these ones, they're off by 1. See how you put it right?
And then when you get to the P,
Before D10. It's 3D10. It's gonna be 3, 4, 5.
it's still 4. It'll be 5.
Right here, it's gonna be 3.
3d10,
I don't know,
46,
it's 5 plus 2.
4d10, and then 5p. Is the S and P.
All the S's are always supposed to be.
So 5p6.
Why? I don't know. Just said it like that. Remember, they're off by 1. Yeah, just 3. The D's though. Remember the D's are like off by 1. No, I have way too many stickers. So I might not take it.
That little bird.
Are you done?
Did you finish that last one? No. Oh, okay.
Oh, I'm a wonder of the best.
I don't know if you can start with arsenic and then go from there.
Okay.
Where?
Right there. I gotta take my
When you put numbers in
Okay.
From the last.
I wrote it.
Okay.
Before you would be wrong.
You got some answers?
My,
We've done one with that before.
wait, so there's no money? Hold on. Wait, so if it's yours.
Okay.
Yeah.
Yes. So I think it was, it was like this. You can only vote for a mouse and I forgot to say below that, and then it's.
Yeah, like.
But we're gonna say it's RF though. Oh. RF, and then you can do RF.
Go off.
And then up and down to the short thing. I think they start off from. So it'd be the EU. RF and little bracket. I think so. But it's kind of, this is actually.
Okay, it's all uploaded. Okay. Okay. So, ready? Okay, so let's see. First question. Okay, arsenic. Let's see. Everybody has a periodic table available?
Yeah.
Table.
2. So then I put 1s1. Six S2.
Okay, what is the symbol for arsenic? Okay, so do you guys want to do it the short way, or do you want to do it the long way, or do you want to do both? I do the short way.
Long
Yeah.
way for the first one and then short way for the second one.
Okay,
Yeah, 'cause
that is, I think that's a good compromise. Long way for the first one,
That's right.
and then the short way.
Yeah.
Okay, that's a good compromise. Okay, so where's arsenic? Okay, what is its atomic number? 33. Right? I know it's, I know it feels like a Monday, but it's actually Tuesday. So you should have got the Mondays out, right?
We got this.
Good morning.
Remember,
It's Tuesday. So where are we started? It's where are we starting?
We are starting at hydrogen.
We're starting at hydrogen, okay, so we start at 1s2.
2s2.
1s2. 2s2. 2p6.
Yeah.
3s2. 4s2. 4s2. Then 3d10.
Then 4p3.
4p. Okay. Piece of cake?
Let's see.
Go ahead.
Okay, what about the short way? Yes. What should be brackets?
What the?
I know it's not written all over stuff. AR in brackets. Whereas you said 3d10. Okay, for the exam, you can do it either way. You can do it the short way, or you can do it the long way. I prefer the short way because you make less mistakes. Okay, now what about europium? What is the atomic number for europium?
So for the short waves, they're always gonna be from the. It's gonna be from the far side of the department.
Okay, so for europium, it's 63.
Oh,
And then we do another gas brackets. Are you sure? No.
Isn't it 18?
What's that?
Okay, so if we remember this, europium is actually located
Oh, I
in
see
this
why.
part right here.
Yeah, it's right there. Because look at the atomic number.
You guys see that?
It's before and then.
So you want to go to the one that will be before it.
Right.
E will be the one before it. Right. So it's Xe. And then. Then. Set.
Oh, you're down. Right.
Because we know that down here starts at 4. So that's 1, 2, 3, 4, 5, 6, 7. Okay. Questions? Concerns? Cash? Kool-Aid? Pay my bills, don't have any money now. Yeah. Okay. You should say, pay my bills and it's like, definitely don't have any money now. Okay. Any questions? Any concerns? Any cash? No cash. Oh, I know about that. Okay. Everybody got it down?
Yes.
Everybody got the correct answer, right? You see the question? Roughly.
So then you just go through, yeah, it's like.
Oh, yeah. See, that's all I do all the time. It makes it easy to grade. Okay.
Hydrogen gas, and then the iron.
Did you take one?
It says iron.
Yep, it's
Wait,
15
so this isn't part of the.
Yes. Turn out. And then
It's wrong.
Okay, let's go ahead. Tell me the chemical equation.
Hydrochloric acid, so you know, HCl. With the iron 3 chloride, so Fe3. Yeah.
Yeah.
Are you just writing on what I'm saying?
I'm figuring out what you're saying.
Is it FeCl3? Is the 3 to be the charge of Fe? Yes, that's that.
Okay.
Okay. Plus H2.
Plus H2.
G.
two in front of the iron. Two in front of the FeCl.
Oh.
And 3 in front of H2.
Everybody agree? Anybody disagree? Okay. Everybody got it?
Yep.
Go down to 15, okay.
Yeah.
So don't look at it. Okay. So let's talk shop a little bit. So this week is a crazy week. I'm actually gonna be out of town tomorrow. We only have one class. Wait, hold on. But we have a review session that will be happening tomorrow. Isn't that right? How you feeling? Sound okay?
Yeah. What do you mean, like Zoom?
It's up to her.
Let's do Zoom. Let's just do group chat and text them.
I could do it on Zoom too, yeah.
Yeah, let's do Zoom, girl, and then come.
You don't have access. Well, you technically have access. What's that?
So I just created an
Yeah. So it's really up to you. Yeah. So, and you guys know you have an exam this week. Did you guys see the practice exam? Did it show up? It did. Because I have a couple of issues on my end. They've updated Canvas. And every time they update Canvas, they make. Are you serious?
I'm only using the
Yeah.
research.
Yeah, okay, so you gotta figure that out. Yeah, actually, all I did was, no, actually, I didn't do that.
Yeah, I
Oh,
was
really?
on time.
Are you serious? Oh, okay, so let me figure out what the hell. There might be some new stuff that's happening. So all I did was I made a business to the practice exam, and then I had to republish it. And I published it. And you're not able to see the exam? Can't see it?
No, the exam's not there, no. Yeah.
Okay, so I need to figure out why. Okay. It's due Monday, yes. I'll fix that as well. Yeah.
Because I just let it happen, I just want to get what I get.
Yeah. I'll fix it, yeah. There's, was it supposed to be that?
Yeah.
Anytime they don't do
I'm
that.
gonna stay until 1:30. I'm gonna stay until 1:30. I mean, I'm not for sure.
So I agree.
Did
Did I say it was? I didn't put some numbers. I put on this, what's the iron?
That's what I'm.
So next time I'll remember to put the Roman.
Yeah, I didn't like that in my head.
Okay, any other questions? So you guys are aware, so the exam is actually gonna be due on Monday, right? Monday at 11:59. Don't wait till Monday at 11:59 to do it, right? I still get those people that at 9 o'clock, the night before, I'll get a message, I'm in bed already. Lately, I've been sleeping really well, you know, so if you're texting me at 11 o'clock or 9 o'clock, you're probably not gonna do it. But before before your kid wakes up or whatever your obligations are, because it means that a lot of things runs a lot smoother, And then if anything happens, then it's enough time that, you can call me, bug me, and sometimes I will not, I'll put my phone down, I will ignore it. On Sunday, I do. I put your mouse over there because I'm cleaning and stuff. When I'm washing dishes, I don't pay any attention to my phone. So, and Sunday is the only day that I do. So, yes. Sometimes it happens. So what happens is it'll show me, like, I'll get it when I look at the exam. And then there's like offenders chart, right? Because the top offenders is something that's line boys, so I'll go to those top offenders and I'll take a look at.
No, I didn't watch that,
Or
but they go
your
on 10
dog,
and I
your
just
daughter. I had this
knocked
one,
out
she had like
they were
3
still
kids and they were
pumping
all
up.
little kids, they were all falling over, and everything while she was trying to take her exam. And so, I'm like, okay, and then I had one case where I had one student who had
I didn't see it.
She would have, but had her, I mean, beard and all. I'm like, you know, I'm like, at least have him dress and drag, so he, you know. So, what was that? He took her exam.
Like a little. No, it's crazy though, like when I was at my. There's only on
Yeah,
Thursday.
it was. I'll see it. But I'll see it. As long as you don't answer it, the text message pop up, and no, so that you would text them to like, and they were actually messaging about the questions. So they pop up about the questions, so I hadn't noticed it get back. So then, you know, another reason why. And you would think, hey, if you're gonna cheat, at least be smart about it, come on, you know. It's just like cheating. Okay. Any other questions?
How many of you guys have done the practice exam? Because I was gonna say, if you guys have any questions about the practice exam, you guys can come ask me tomorrow. But you guys don't have to do
Okay, so let's talk, we have to finish about electron configuration. Are you guys feeling comfortable with electron configuration?
Yes.
Yes?
Configuration, yes. The only thing that I think I'm gonna struggle with is, what was you saying? This stuff.
You're not comfortable with that?
No.
Okay. Okay, so we'll talk about that. We'll brush up on that. And then, so let's pull up the notes.
Showing?
Okay. Let me print this page real quick. Are you supposed to still have your boot on?
I think so.
Dead.
Okay, so real quick, let's do a brief go over. So let's say we have blue light. Blue light, we'll say at 450 nanometers. Okay, so what I'd like you guys to do, if we have blue light that's 450 nanometers, I would like you guys to calculate the frequency for this. So how would I go about finding the frequency for blue light?
Yeah, I think that was it.
Okay, you said, what about the speed of light? This is the question.
Speed of light divided by
Okay, so C equals,
The seating was to the right, that little white.
So lambda is wavelength. That's right. Nu is frequency.
Yeah, new.
Okay, so we're trying to calculate what? Okay, so how would I change my equation?
We devise a little lightning.
Yeah.
What does it say?
Okay, so nu would be equal to
Wait, what's it called?
nu, as in I got new shoes. Nu.
Oh, I think it's.
Nu equals. Like lambda. Okay, and we know that C equals 3. Zero, zero. Times 10 to the 8. What are the units? Okay. And then our new 450 nanometers. So how would I, are the units? So we gotta change it. How do I change it? So we put 1 meter. That's right.
Get you like a writing pad,
Yeah,
like electronic, right?
like I've had.
It's driving me crazy.
Yeah, the S is
And
like
it'd be so
fires.
faster for you though.
Oh, yeah. Yeah, I actually had one, but I broke it this week.
I wonder how.
So is it 4?
Okay,
So then, nanometers,
Wait, what is that? Though? Is that 10 miles?
That's about 1 nanometer.
so I'm getting 4.5 times 10 to the I don't know.
yeah, so that's what that. 1.5. It's minus 7.
Here,
Okay. And then on top we have 3 point.
Oh, it's 4 point.
It's a 9 over here, but -7.
Is that a -7? 4.5 times 10 to -7?
Yep, that's what I said. 6.7, yeah. I mean, stick fix if you have.
Yeah, I just said. Oh, nice.
7. Yeah. 14.
Right?
First. Okay. So I heard energy equals H times nu,
Yeah, 10.
H times nu. And we know that energy is six point six. 10 to the negative. Yeah, that'll be given to you guys. Then we multiply that times 6.7.
Maybe it was
14. And we know that, yes. So heading away.
How did you get the -7?
Is it from the 9 and the 8?
Yeah, it's from the, you see, here, let me write on the camera, so it'll be
Okay,
easier to
yeah.
see. Show my camera.
Just like the real. Oh,
Okay. No, that was the second one. Yeah, because it kills first that cricket. That was really good.
So if we have 450 nanojoules,
So it does not.
and we want to change that to meters. Okay, so if we have, right, is at the bottom. So that's the same thing as saying times 9. Just here is 450 times 10 to the -5, which is the same thing as saying 4.5 times 10 to the second. Right? So if I have 4 times 5 times 10 to the second times 10 to the 9 minus 9, then we just add the two exponents. Right? So then I'll get 4.5 times 10 to the -7. You guys see it?
So I mean, yeah. Yeah, I see it now.
You guys got that? I know it's that you guys are still a little rusty on that math part, those exponents and stuff. It's everything. It's everything. And if you screw up putting it in, it's screwed everything.
Oh, yeah.
Okay, questions, concerns, cash, relate? Okay, let's go back to the problem. What did you guys get for energy? So we know that energy is. So then, that 8 plus 6, like 626 times 10 to the 4 joules seconds. So then, find that one. Seconds. Wow. You said we get it. Just scared me. I was gonna leave back on the door. Okay. Questions? Concerns? You guys got it? So you guys will see you'll have at least one question like that on the exam. It should be a piece of cake.
Leave it up there for a minute.
Six to eight.
103?
10
Oh,
points.
103. And then the S is control, and then it equals 4.4.
I always like to make you think a little bit. Okay, so if it is this chemical, what color will it be? Chart that tells you. Okay. Any questions? Okay, good. So let's move forward.
Okay.
Okay, so remind me, how many electrons can fit in an orbital?
So what?
How many electrons will fit in an orbital? 2. Okay, so how many orbitals are in each sunshine? How many are that? That's right. Say that again. S has 1 orbital. So how many electrons can it hold? 2. Okay. P has how many orbitals? Okay. And how many electrons can it hold? And then we know that D has 5, right? Almost 10. And if there was a G, said, we'll talk about this is what the electron is doing. This is the nucleus. Here, we have the electron that's circling the nucleus. And so this was based upon, like I said, this is based on Bohr's model. But Bohr basically thought it was, a two-dimensional one orbit like this, but it's a three-dimensional type of orbit. So this is the quantum model. This is Bohr's model, right? He extended his model later on. Now, Bohr was almost right. It worked really well with the hydrogen atom because it had one electron. It became more complicated because we know that benzene has how many electrons? Benzene. It has 23, right? Okay, so it has 23 electrons it has to be concerned with. And so when we look at the different orbitals, we look at the different orbitals or the different sublevels, the different sublevels. So the S sublevel is circular, right? And so the electron is moving in a globe type of shape all the way around it, constantly moving around. If we're talking about the P, if it's in the P, the first orbital, which we call the PX, right? It's going to be a little dumbbell, it's going to be like a dumbbell. So it's going to be moving like a dumbbell shape. We have one that's going to be in the PZ. It's basically on the Z axis, right? And again, dumbbell shape. And then the third orbital would be PZ, and then PY. Okay. So, and it's going to be constantly moving around. And it's always moving, right? Always moving. And so the electron is going to around in that fashion. This here is the PG. These are the different, all of the different orbitals that it has in the D sublevel. Okay, and then the F is really complicated, so they never show it, right? So there's a couple of people that have tried to depict it because it's really, really complicated. So you kind of get an idea. You don't have to know this, but you need to know that there's orbitals, right? And then these represent those orbitals. Okay, so remember I talked about the Russian dolls. So this is kind of an example of the Russian doll, right? Here. So if we take a look at the 1s, the 1s is right here. It's like this big, right? And then the 2s is going to be this big. Then the 3s is going to be this big. Now, those electrons are moving in that sphere shape, right? The ones that are in the 3s are moving here, but you have the ones that are in the 1s that are there too. And so they're not interfering with each other. And it's really important you guys understand that, because if an electron interferes with another electron in another orbital, that causes a disturbance. So that's how we get that shoot stuff into the atom and stuff like that, is because you fuck with electrons that shape or that usually if you're trying to shoot it in, you're trying to shoot it in, so there's great movements in this, and you miss those electrons, which causes a lot of energy to happen. But if you screw up, you cause huge explosions, right? And so it's important that they stay in their orbit, otherwise they will affect the other electrons. And those causes huge explosions, cause energy disasters that are incomparable to anything else, right? So that's the case of like a nuclear explosion, right? The result of a nuclear explosion is a result of electrons that are being screwed up, right? Because you're shooting something into that nucleus, it shoots off those electrons. So that's why nuclear bomb is just like for that. Okay. So Pauli exclusion principle. You gotta need to know this. It's gonna be on the exam. They're gonna ask you about it. Now, the Pauli exclusion principle basically says that you have the possibility in an orbital to have something that is unoccupied, meaning that you don't have anything in it. You have one electron in it, or you can have two electrons in it, right? But you can't have more than that. So you can only have two electrons in any orbital. Now, normally, what you do is that you want to fill up each orbital with one electron first. So like for instance, take a look at the, let's put this on the side here. So if I have P, this represents our P, let's say 2P, right? And we're putting in electrons in this 2P. Put 1, this represents an electron, in each orbital first, before we go back and put in the other. Okay, so if we're adding electrons, what happens is that we make sure that it has 1 in each orbital. Now, sometimes, well, we have exceptions. Sometimes energy levels are so close together, like for instance, the 4s and the 3d, right? They're really close. So the 4s is right here. The 3d is just a little bit above it, right? So what happens in some cases, and what it'll do is, since they're so close, it'll fill up. 1 in each of those orbitals. We'll go those 4s, put 1 electron there, and then put 1 in the 3d, and then put 1 in the 3d, another one in each of the 3ds. Okay, so let me write that so you guys can kind of see what I'm talking about. So we have 4s. 4s is technically more than the 3d. So for instance, if we have chromium. Chromium is one of those special cases. It's an exception. So what chromium does in that 4s, it'll put 1 electron in the 4s, and then it'll put 1 in each of these in the 3D. Because that energy level is so close, and it's a lot easier for it to do that than it is for it to put the second electron. So this is what we'd expect it to do. Right? This is what we'd expect chromium to do, right? Because it has 4, the way we read it, it has 4 electrons in the 3D, right? We're talking about chromium. Okay, so does it have 4 electrons in them? Okay, so we would assume that it has 4 electrons, but really what it does, it has 5 electrons in the 3D and it has 1 in the MS. So in actuality, this is what it does, because that energy level, they're so close together, and it's easier for it to do it that way than to. And let me explain why. A second. Great handwriting. So it does that instead. Now it does that because it's a lot stabler to have positive charges. It's kind of like, have you guys seen when guys go out and they go to a movie, they always leave like these seats between themselves. They don't do it now because of COVID and everything don't together. But before, guys would always take a whole row and they would sit. I always say it's because you're hoping that some girl comes and sits next to you, right? That's what it was. But typically, this is what guys would do. They sit there, like I told you, like little love seats and everything like that. And so it's better for it to sit there and feel and occupy all of the vacant positions because it's less energy than having one thing in that. To use the least amount of energy as possible. Just like you guys are. You're going to find the easiest way to get that A, right? Right? Oh, not 8. Look at this. Okay. So we've already talked about electron configuration. You guys should be pretty comfortable with that. Now I'm going to add another layer to electron configuration. Okay, so we know what an ion is. So if we have ions, so it's going to have so if we're removing an electron, that means it's going to be a positive charge or a negative charge. gonna be a positive charge. Okay, so let's say we're talking about titanium, and we have titanium. I'm gonna write it here. So if I have titanium 2 plus, what would be the electron configuration for titanium?
We're gonna remove 2, right?
We're gonna remove 2. So first let's do titanium to make it a little bit easier. Titanium. We have brackets. A. Or as okay. That is the question. Okay, so now here's the secret. Now, when you're taking away electrons, when you're removing electrons, you're going to look at the period. You're going to take away from the highest period. Right? Which is higher, 4 or 3. So we're going to take away from there first. Right? So if we take away from there, we're taking how many away? So then all this could be less. Okay, so when you're taking away electrons, you're always going to take away from the highest period first.
And then on the top is 4s2. You're gonna remove the 4s2
That's right, first.
and just leave the 3d2.
That's right. Okay. Okay, so let me give you another example. Let's do. It doesn't actually. It doesn't, because it's lower, it's always one of the lowest energy. That outer shell is considered to be the highest energy than that. Higher period is considered to be a higher energy than the lower. Lower. So, 7 plus. Okay, first off, what does IN look like? What will be the electron configuration for IN?
Brackets.
-2. Okay. So then. Okay, so then 7 electrons, where are they going to be removed from?
4.
So we're going to remove. Okay, so we're going to remove from here because this one's highest. This will be the highest. And then we remove the rest from here. So 3, 4. go by the bigger number, and then the one that has the most gold. P is higher in energy than the S is.
So they got that P first, and then
So, okay, so in terms of energy level, right? So we just know S is going to be lower in energy level than, so 2S is lower than 2P. Right? 3S is going to be lower than 3. P is going to be lower than. So each, and then F is.
basically the strongest one.
You're gonna remove these first, and then, because this is a lower period. Okay, questions? Now, if we're adding electrons, it's just easy, we just add electrons, right? So if we're talking about arsenic 2 minus AS. So what about that? Electron configuration for arsenic 2 minus. That would be arsenic. Arsenic minus. Ten. 5. As long as it doesn't go over, that's it. Yeah. Then that means it would go through. So often when you're getting multiple choice questions about electron configuration,
There'll be something like this. That's a
okay, they'll give you something like this as one of the options. And you know that's not right one. Because we know that S can only hold how many? Two, right? And which that. We can only do that, right? Do I see that? Okay, so those are some of the quick ways of determining with electron configuration. Questions, concerns, cash, credit, Kool-Aid? You guys look tired. Still got 20 minutes. You gotta hold off for 20 minutes. Okay. Okay, let's see how good you guys are at this. So let's say we have so write the electron configuration for this guy. And let's do
I think you are. No, you said that. I'll be like, next could be. Yeah, I know. Plus it's
Look at the 8.
we're
Wait,
seeing.
wait. I know why. I know why. It's talking about. For support, the PD was 6. With 5%. But did you? Because that has a high charge.
What?
That has a high energy. No?
Or like the original.
Okay, you got some answers?
Yes.
Yes, maybe.
Okay,
I wanna
so let's,
First one, I think I did.
okay, so for PD, what do you guys?
So originally we used KR with brackets. And then you would have to add 6, so
Minus
would
6.
be 42.
This one?
And the C. So 4 more, so it'd be 44.
Now for
40.
burial to
I would like that.
Yeah, that would be unstable.
I don't care whether you.
Okay,
Concern.
so you guys got a whole nother layer. We have to? Do we have to?
Do we have
Of course. Thanks for enjoying it.
Did you take an early break?
Early break.
And then I got these.
Okay.
Yes.
Okay, so.
So when we write after we put that core in there. Let's see. Let me see if I can.
That could have a different.
Okay.
Did you get it? It's on the right. It's on. What kind of did you get? It's not as white.
Okay. So it helps us determine what electrons are going to be valence. Valence electrons are going to be the electrons. Okay, right? Are going to be the electrons that are involved in bonding, right? They can be used for bonding, right? So you have what we call your core electrons. Those core electrons, those are going to be used to maintain that element, that atom, okay? You don't want to mess with that core. It's kind of like the money that you have in safe. You don't want to touch that money, right? That money is saved up for that house or that car or that. The money that's in your checking account, that's the money that you touch, right? So the electrons that are going to be electrons that you touch. So valence electrons only really apply to the main group elements. So you guys remember when we talked about the main group? Talked about it really briefly, where transitional metals and stuff like that, those aren't considered to be the main group. So those guys, they don't obey the valence electron rule, okay? The groups 15, 17, 16, basically down to 13. Those guys are going to obey the valence electron rules. Okay. Now, when you're talking about valence electrons, you're going to be looking at your P and your S orbitals, P and your S. This tells us how many valence electrons there are. Those are going to be the electrons that we're going to be used for bonding. So if we have a D, we don't want to touch that D, right? If it's full. The only time we ever touch that D, if it isn't full, right? If it's full, it's going to be stable, right? So that's the P and the S. P and the S are the ones that we're going to be using for bonding. Okay. So how many total electrons can you hold with the P and the S? We can hold 8 electrons. Okay. So if we take a look at tellurium, Te, it has how many valence electrons? It has 6 valence electrons. Okay. One way that we depict valence electrons is by showing the Lewis match section. You just put dots around it. So it has 6 valence electrons, 6 match. Okay. Neon. Neon is a noble gas. Ne What is neon's electron configuration? One S2, 2S2. So we would only take the ones that are in that second period. How many valence electrons are in neon? 8. So it's not really valence electrons, but it has 8 electrons that will be surrounded. So we would draw neon like that. Okay. Now 8 is where you want to be. 8 is called our octet. We want to reach our octet. Tellurium is missing 2 electrons. So when it gains its 2 electrons, okay, let us know that it's gained its 2 electrons by putting the charge on the outside in brackets, and then we draw those dots in. We add those 2 electrons to it. Okay, so again, this is called Lewis dot structure. Okay, so I have oxygen. So draw the Lewis dot structure for oxygen.
Okay, but it's only S and P. The one.
So the valence electrons are always going to be the electrons that are out of those shells. So they're going to have the highest period, right? So those first two are in the 1s, right? So we don't take those in consideration. We only take the ones that are in the outermost shell. Okay. So what is the electron configuration for oxygen? Two P4. Okay, so then how many valence electrons do oxygen have? 6. So how many dots should I have? Okay, now if it gets 8 dots, it's going to be happy, right? It's going to be like a noble gas. And its goal is to try to get like a noble gas. So if we become O2 minus, what would be the electron configuration for that? I mean, well, let's do the electron configuration. Then we'll do the. Okay, so it's just going to be O2 minus 1s2, 2s2, 2p6. Okay, so then its Lewis dot structure is going to be 8. Put some bracket around it. Okay. We'll get there. Okay, so that's our Lewis dot structure. Okay, so that would be the Lewis dot structure of that ion. Okay, questions? Concerns? Pretty simple so far, right?
Not too bad, not too bad.
Okay, good.
I'm not grouchy today.
Everybody got it?
Yeah. Not all of them.
Yeah.
Okay, so this is just showing you exactly what we just talked about. Right? The number of valence electrons, its fluid structure. Okay. So often on the exam or on the ACS exam, they have questions that are kind of like this. They'll say, write the electron configuration for the highest occupied group 6A/16. A 16 elements. So what well, group 16, who's in group 16? Okay. So the Chalicans. Who's the major player in there? Oxygen. So we know oxygen, which we know the electron configuration. All of those that are in that group, they're going to put in meaning any number, right? They're always going to end like that. Everybody that's in that group will always end like that. Okay, so they're basically asking you for this question is no, not what's in. They want in. They just want this part. They want to know the valence electron. Right? So which valence electron? Everybody in that group are going to have the same valence electrons. It's going to have right? So oxygen is period 2, right? So it's 2 for N. If it's sulfur, then it's period 3, then it's 3 for N. Right? So, but everything else will be exactly the same. So it's kind of a weird question, but a question like this is just asking you to write it in this form. NS2, NP6. Okay, so if I'm talking about NS2, NP2, which group am I talking about? Because we know it has 2 valence electrons in the s and it has 2 valence electrons in the field. That's all that question is asking. Does that make sense?
Yeah.
Yes.
And there will be, I guarantee you, there will be like 3 or 4 questions that pop up either here or in the ACS exam. Okay, and so remember when I told you it's about being able to translate what is being said. A lot of times you guys know that information. It's just translating what they're asking for, right? Okay. So we're going to talk about the octet. 8 is the magic number. Everybody want to have 8 around them, right? So your goal is, if you're an element, except for the transitional elements, right? You want to have 8 around you, right? Everybody, all the other elements want to try to get to the point where they have 8 around them, or have none around them, which would be the same thing as 8 around, right? Okay. Okay, so let's talk about trends and atomic size. Okay, so if we look on the periodic table, okay, as we go from on the periodic table, put my periodic table. Okay, so as we go from left to right, it gets smaller. Okay. So from left to right, it gets smaller. Okay. Now you're going to ask me, you're adding more electrons. As we go across from left to right. Okay, so the reason why it gets smaller is because protons are located in the center, right? You have more protons which have more charge associated with it than having less protons. So it's pulling those electrons closer, right? Because it has more protons in the center of the atom, right? And all the protons are going to be in the center. It's pulling all those electrons around it closer because it has a stronger charge, right? So the less protons you have, the less. So it's going to get smaller because it's pulling it closer, right? Okay. Now, but as we go down the periodic table, it's getting bigger. Okay. Green meaning bigger, red means small. Okay. The reason why it's getting bigger is because remember we talked about the Russian dolls. So then we had another layer. 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 Right. So each of those periods are going to be layers that are going to be added on where the electrons are rotating. Right. So that very first layer is going to be really tiny, but the really large layer here, it's going to be huge. Right. So the biggest atom on the periodic table is going to be francium. Smallest atom is going to be hydrogen. Helium. Hydrogen is bigger than helium. So they're pretty close together. Does that make sense? Right, because hydrogen, larger, smallest. Okay, questions? Okay, let's see if you guys got this. Okay. Refer to the atomic table. List the atomic number 16, 15, 16, and 33 in order of increasing atomic size. Okay. Atomic number 15. Arsenic? 15? What is 15? Phosphorus? Okay, phosphorus, sulfur, and arsenic. P, S, and AS. AS is going to be the biggest. Pac-Man eats the bigger one. Okay, who's going to be the middle? That's right. And S is going to be the smallest. Because that's right. It's more to the right, right? Remember. That's right. Okay, because the size decreases as we go from left to right, right? Who is further left? I mean, sorry, who is further right? Sorry. Sulfur, right? So then that one's going to be smaller, right? Okay. And then phosphorus is going to be.
So what is greater than hydrogen?
That's million.
Smaller, smaller than. Okay, yeah, so.
Looking good?
Here's phosphorus, here's sulfur. Sulfur is gonna be smaller than phosphorus. Okay, and then arsenic is gonna be greater than both. Because we're at the next level. Okay. You guys got that? So it gets bigger as we go down. And it gets smaller as we go from left to right. Sure. Okay, so let's say we have, let's go. Okay, so let's say we have atomic number 29, atomic number 48, and atomic number 30. 30. Say 48.
Oh, it doesn't matter. You can see here when it gets smaller. Copper's the smallest.
This is bigger, this one. And that one is smaller.
Copper's the smallest. Oh, shoot, I didn't see zinc. Yeah, I didn't see
Yeah,
zinc.
zinc would be
Zinc is the
smaller.
smallest.
I got it early this morning. Okay, let's take a quick
Yeah,
out of that,
yeah.
and then.
No, cadmium is the biggest.
Yeah, it's just a, I didn't need you guys here.
Yeah,
We can do that
copper's on the
too.
right. Oh, to the right, but cadmium. Zinc and cadmium are more to the left.
Take a break.
Okay, are you guys good? Okay, so what is our answer here? Okay, so what are the, what's atomic number 29? Cu.
But it's also going to.
30? Cn. Okay. And 48. Okay. So who's going to be the smallest? Ben?
You.
Okay. Piece of cake?
Yes.
Okay, good.
Even though it's more to the right. It's not.
So
Ionization energy. Ionization energy is the energy that is required to remove one electron from a neutral atom. Okay, and it's in this gaseous state. Okay, so how much energy does it take to remove one electron? Now, this is going to be kind of dependent on whether or not you want to lose electrons, right? So, for instance, if we have metals like, say, aluminum,
sodium, those have one of these,
right? Because where are they located?
so
What group? Sodium. Group one metals, right? So we know group one metals want to get a +1 charge, right? Because that's going to be stable for them. They're going to be anxious to lose that electron. Where something like a halogen, you guys know who are the halogens? Some of them are diatomic, yes. Actually, all of them are diatomic.
that group 17, those guys, and they don't lose electrons.
They want to gain electrons. Now, if you're like this close to reaching that goal, and I'm like right here, are you like, oh, no, you're this close to getting that A, right? You're, don't give me those points, right? I don't need that point, right? You're like this, because I mean, I get those calls, you're like 0.9999 from getting that A, right? You're like, you're like right there on the edge. You're like 89.9999. You're like, I'm not good. Asterisk, okay, I'm gonna say that. Huh? No,
Curve it round.
I know. If you're at 89.99999, you gotta get your A, right? So either you've done extra credit in the past when it was offered, or you do a test correction,
Oh, that's
or
inside.
tough shit, right?
Yeah.
Well, you didn't care enough, right? Why do I care, right? Yeah. Okay, so the thing is, you're that close, right? You're not gonna want to give it up, right?
You don't get that. You don't get to sit there and come down to,
Can I do that test correction? Or you're gonna do it in the last minute. I'm gonna do that test correction that he kept talking about, right? Because you're that close and you really, really want it, right? Okay, now the electrons that the halogens want, they want one electron. They're that close. They need just one to be like a noble gas. They're not gonna want to give up anything, right? So if somebody comes and tries to take your electron, right? Take that A from you, right? You guys are gonna fight a little bit.
A lot of it.
A lot of it. Okay, that's good. That's good. So they're gonna fight a lot of it, right? So they're gonna be higher than something like sodium. Sodium is gonna be lower in energy. So it's gonna increase in energy. Correct. You just think about it. The one that's closest, they're like, oh, I can lose an electron. They're gonna be happy to lose an electron, right? But the ones that are really, really close to being a noble gas, and they need an electron, they're gonna be like, hell no, you're not taking it. I will kill you for this, right? It's kind of like, fighting for that, your life or something, right? That's what it's like for them. They really need it, so they're not gonna want to give it up. So if we take a look at the energy level,
it's going to increase as we go from left to right.
so it's gonna get bigger as we go from left to right. The ionization energy. Okay. And then as we go from top to bottom, it's going to get smaller. Okay. So Francine has a really, really, it's kind of like, okay, so you're going to be really protective of one kid. My girlfriend has one son, and she's like helicopter mom. It just drives me fucking crazy. He can't go anywhere with it, can't go to the bathroom or anything. I'm like, he's old enough, he can go to the bathroom by himself. She's gonna want to take him to the bathroom until he's like 21. That's the way it's gonna be. And we keep fighting about is one of the things we fight about constantly, right? Because he's her only one. Now, I had another girlfriend, we had 9 kids. Right? She was like, she was just like, I don't care, right? And so she's like, yeah, exactly. She can go half of where they're at half the time, right? So big differences, right? Huge differences in terms of their parenting, huge differences, right? And so the thing is that the more electrons you have, the more you're like, you can take it. Go ahead. I don't care, right? So francium is way down here at the very bottom, so it's going to have less ionization energy than hydrogen does, right? Because hydrogen has that 1 electron. It's going to want to keep track of it a little bit, right? But francium is going to be that right? Because it has so many. Right? So big, so do whatever you want to do, I don't care, right? So it's going to get, again, smaller as we go down the periodic table. Okay, does that make sense?
We meant to come back, but then, yeah.
We got lost along the way, right?
Honestly, we were
Okay, so
Oh my.
okay, so when we talked about the ion, basically, you know, the sodium ion will remove 1 electron. Now that energy that it takes to remove that 1 electron, it's going to be really low for like sodium ion. It really wants to get rid of it. It's like, go ahead, take it. It doesn't matter, right? And it's going to be even lower for francium, right? Because we know that francium is at the very bottom of the periodic table. So this here is just the trend. There's hydrogen. It takes a lot to take away the fluid, right? Now helium is another gas, and since it's another gas, it's already stable. So if you're already stable, you're perfect, everything's perfect, you got a perfect man, you got a perfect amount of money, you got everything's perfect. You're gonna let somebody, a home wrecker, come in and take your man, take your perfect. No, you're gonna break that, right? You're not gonna let that happen, right? So you're gonna be like, you're gonna play with all your energy. So it's gonna be very high energy. Sit there, remove that electron. Everything is perfect. You don't want to screw up a perfect thing. Right? Okay, so remember gases are going to have the highest ionization energy, right? But group 1 metals are going to have the lowest ionization. Further down the periodic table, here you have sodium. You have lithium, you have sodium, and then you have potassium. As we go further down, that ionization energy is going to be lower for us. Okay. And then here, helium has the highest ionization energy. The neon is going to have the second highest. And then you go down, and then it starts to vary. But you can see the trend. Okay. Now, the second ionization energy is the energy plus 1 charge, right? So in the case of magnesium is going to be really cool. Its ionization energy, its second ionization energy is going to be really good. It's going to be really low compared to magnesium plus. Okay, so because it wants to lose 2 electrons, right? So it's going to have lower ionization energy after it gets rid of that first electron. Does that make sense? And then the third ionization energy is the energy that's required to move 1 electron after you already have a +2 charge. Now, who's going to be happy to lose 1 more electron after this? Who has a +3 charge? Unusual 13. Yeah, so aluminum, right? Aluminum is a perfect example. So aluminum, its ionization energy, if you go from its ionization energy, second ionization energy to its third ionization energy, right? It's going to be very low energy to get to that. So here's the trend. Ionization energy is going to increase as we go up, and it's going to also increase as we go from left to right. Ionization energy to remove and single. List each of elements in order of increasing first ionization. And and want to list it in increasing ionization.
Good. That's good.
Smallest of these.
Okay.
It's increasing. Which means from low to big. Yeah, that typically what happens on the we talked about, yeah, we got it. And then they take the exam and then they'll write it. You know,
I think because we're just so trying to.
yeah. Everybody get an answer? Okay. So it's going to be the smallest. It's the bigger one. Okay, so first ionization energy is the loss of that very first.
So that's what I'm doing.
The loss of that second electron, this would be our second ionization. Okay, so we have sodium, right? Start with sodium. Its first ionization energy is low. Okay, you guys know that because we just talked about that, right? So its second ionization energy, is that going to be low or high? where sodium is located on the periodic table. It's that one electron. So it's lost one electron like a noble gas. So if it's like a noble gas, is losing an additional electron going to be easy or is it going to be hard? Oh, stable. Got a 50-50 chance. Is it going to be easy to lose that second electron to get once it's a noble gas, it's going to be harder, right? So that means it's going to take a lot of energy to do it, right? So here, this is acting as if it's a noble gas because it's stable. Once you get to stability, are you going to let somebody knock you from stability? You guys, have you guys had that friend that you get around and see? That was my friend I went to Vegas with. Let me tell you. Oh, yeah. So anyway, you have that friend that when you get around them, they drag you in the gutter. You guys have any of those friends?
No, I cut them off.
You cut them off, exactly, right? You gotta cut them off, right?
The what question? The toxic things?
What was that?
The what?
So the question was, do you have that friend that drags you in the gutter?
She went by my.
She went by that, right? You cut them off, right? Because you like stability, you want stability, you want stability. You have that friend that, you know, that druggy friend or that, you know, the one that go blows $1 million at Vegas and, you know. Everybody has a friend like that, or at least had a friend like that in the past that you're like, okay, keep your distance, right? So once you're stable, you don't want to run with that person anymore, right? When you were young and dumb, you know, you used to run with that person, right? But once you get stability in your life, you have a kid, you're getting settled down, you're making good money, you know, you start running with that person real quick, right? Okay, so that's exactly what's going to happen here. You have stability. You're not going to let anybody disrupt that stability. So it's going to take a lot more energy. So if you're sodium plus in A plus, right, you're just like a gas. You don't want to give up that stability, right? So you're not going to let somebody else take an additional electron. And that's what happens here. So its second ionization energy would be really, really high, right? We'd expect sodium plus to have a high second ionization energy, right? Because it is so much energy to sit there and remove that electron. They're going to fight you for it, right? So, but that first one is going to be low because it wants to get to that plus state. Now, magnesium, on the other hand, would we expect its second ionization to be high or low? Low, because it wants to get rid of 2 electrons. Okay, does that make sense? So if I have this, so to get to this, we would expect this ionization energy to be high or to be low. From F to F plus. So its first ionization energy, we expect it to be high or low? Are you sure? Okay, look where fluorine is at. Where's fluorine at? Okay, now the thing is that it doesn't want to lose an electron, right? So it doesn't have this, right? If you're a taker, you've been a taker your whole life, you're not gonna all of a sudden be a giver, right? You're like, no, I've been taking my whole life, you're gonna be a taker, right? And somebody that's gonna make you give, you're gonna fight them every tooth and nail. You're not gonna, I'm not giving you shit, right? I've been a taker my whole life. I'm not gonna all of a sudden change and become a giver, right? And so fluorine wants an electron. It doesn't want to give up an electron. So it's gonna fight tooth and nail to sit there and not give up an electron. So it's gonna be a lot of energy. Okay. And so you want to think about it kind of logically, right? In a sense, you're so close to being where you want to be. You're gonna let somebody come and take your stuff.
Got it.
Okay. But if you don't care about it, like, you know, I have extra. Then you're like, well, yeah, you can go ahead and take it. You're not devastated, like, you know, little rich kids, right? Do they care if somebody steals their stuff? You know, they're like, no, mommy, daddy, go buy me another, right? Story. My girlfriend's son, right? He's not a rich kid. but she buys in everything outside, you know, over there. I mean, sometimes we've been dating for now almost 2 years, maybe 2 years in. And then he's lost, I'm gonna say probably like 8 different toys, right? And I'm like thinking, my mom would have beat my ass, you know, just like she would have beat me like, you know, I paid good money for that. You're just gonna leave it outside? Oh yeah. And so I get on him about it. She's, why are you getting on him about it? Because your stuff, it's gone, right? And then so when he does that, I take it, I put it in the house, and then I'll keep it. I'll keep it until it comes up again. And then I said, remember, you keep losing your stuff. I said, I'm gonna start giving away to people that really want it, you know? If you have extra, you're like, I don't care. Or if you can get anything you want, I don't care, right? You don't care about it. But if you really need it, you're like, man, I just need to get one more. You really want it. You're like, fuck, I'm not gonna give that up, right? You're gonna definitely make it harder for them to sit there and take it. Like somebody robbed you, you're down to your last fucking gas money, right? This is the money for the week, you know, or for the month. And somebody wants to rob you, you're like, fuck that shit, right? I'll fight you for this. We're gonna fight over this, you know. So, but if you have extra, you're like, oh, here, just take my wallet, you know, here, take my jewelry, you can take the car too, right? Because you don't care, it'll be replaced, right?
So that's kind of
Yeah. Some examples, someone who's not like that, is that like nitrogen and phosphorus.
So nitrogen, they're in the middle, right? They're not gonna be as, you know, their energy isn't gonna be as high, but they're still gonna be pretty high because they wanna gain electrons, right? They want electrons, they don't wanna give up electrons.
So what's higher energy? Is that fluorine becoming neon or neon?
Neon losing is high, right? Because you're stable already, right?
But wouldn't that effectively be, I mean, it's the same.
Yeah.
Yeah, so if you're stable already and somebody's taking for unstable. Exactly.
If you're on.
Yeah. Okay.
Okay, I remember, now I'm scared.
Okay, so we've already talked about the chemical families. We've been talking about them throughout the whole semester. So you guys already know group 1 is called alkali metals, right? So when they form an ion, when they become plus, they become isoelectronic. Isoelectronic basically means the same number of electrons. So they became the same number of electrons as the noble gas. So that means they become stable like that noble gas. So they're going to try to behave as such. And since that's their goal, right? So this is some of the chemical families. So these are group 1 metals, right? And these guys, because when they're in their natural state, they're not in their natural state, they're going to be more volatile, right? Because they're so anxious to lose that electron. So literally, lithium metals interact with so just that little bit of vapor will cause it to explode. I told you guys. Yeah, and it blew up the light. So that's the example here, right? So all of these guys, they're so like they just want to get rid of that electron. They get rid of that electron, they're very happy. So they're going to be quick to react to that. Where chlorine, bromine, fluorine, those guys want to gain more electrons. So they're doing anything that they could possibly do to gain that electron. Yeah. You guys got that? Right? Okay. So who are going to be the most volatile? So who do you guys think? Who do you guys believe will be the most volatile? Right? Who's going to be really anxious to get rid of an electron? So group 1. Group 1. Okay, so these are, yeah, so those are all examples, right? But who do you think is going to be more? Right? Say hydrogen? Now, think about it now. I want you guys to think about it. What's that? Why, friends? Is it the smallest?
I think it's.
It's the biggest, right? It's also gonna have the most ionization energy or the least ionization energy. Yes, it is the biggest atom and it has the least ionization energy, right? So that motherfucker is gonna be like, you know, so it's gonna drop it like that. It's gonna be very hard, right? So, okay, now who's gonna be in terms of gaining an electron? Is that gonna be gaining an electron? What was that? You said fluorine? That's correct. It's gonna be fluorine. Fluorine is like a bully. It is like, yeah, you're gonna give me that electron whether you like it or not. I will take it, right? Okay, so because it's the smallest and it's so close, it's like, and it's so strong compared to all the others, right? So do you guys see the distinction where, you know, Francis is low in energy, it doesn't, you know, it's like, eh. Okay, are you with me? Okay, you said no? Now you are, okay. Good. Now, these are types of questions that they're not gonna ask it like the way I ask it, but these are the type of questions that you will get. They will say, you know, which one has the most ionization? So you guys should know it. So you guys should be able to do that. They're big questions, you know, big picture questions. That you can calculate that ionization. Okay. So you want to just kind of think through it. Okay, so you guys are already familiar with all of the chemical families: alkali metals, alkaline metals, transitional metals. These are the lactanoids, these are the actinoids, these are halogens, lactanides on the noble gases. You guys know what it says? Solid. The ones that are on the paper. Okay, so you guys got that? Good. Okay, so this is where I get that. So these are some examples. You guys got a chance to see some of the metals last week. So we already talked about the noble gases. So those guys are going to react. So they will react if they're forced by some other element. Somebody's picking at. That's the only time. So these are the halogens. These are characteristics of metals. So metals are going to be they're going to be lustrous, meaning shiny. They're going to be ductile. That means that beat down and expanded and stuff like that. They're going to be malleable. More metal like as you go from right to left. Okay. So that makes sense because over here you have non-metal, right? And over here you have metal. Right? So you should be able to sit there. The more metallized you are. Okay. Non-metals are typically dull, brittle. They're going to be poor conductors of heat, poor conductors of electricity, or they're going to be gases, right? These are some characteristics of metals and non-metals. Just showing you where they're located. This is just showing you trend and how it can. Questions? Cash? Kool-Aid? Excellent. Okay, so before we get started with the lab, we're going to have to get started with the lab real quick. Go over what we went over before. So So we talked about types of bonds. Okay, so we already talked about types of bonds. You guys know what a cation is and an anion. So a cation and anion. So we've already talked about ionic bonding. Okay, so you guys already talked about what isoelectronic is. So when they become the ionic, the reason why they do that is because they want to be like that gas. So electronically, they want to use that. So these are just examples of ions that are isoelectronic. Okay, this is just showing. Okay, the ones that are in green, they're all going to be isoelectronic too. The ones that are in blue, those are all going to be isoelectronic. Yellow, those are going to be isoelectronic. You guys don't have to look? Or you? Yeah. I mean, you guys go. Okay. So again, isoelectronic just basically means the same number of electrons. So again, that term isoelectronic, same number of electrons. So these ions, all of these ions will have the same number of electrons as okay. Same number of electrons. So calcium, the calcium ion, it's going to be isoelectronic too. Okay, so what will be its electron configuration? Calcium ion.
Argon and brackets, and then do,
Okay, you said it's going to be argon in brackets.
right? And then-
So what should be the charge on calcium? Where it's iron, 2+. Argon in brackets.
Four S2.
4s2. Calcium. It's calcium 2+. So what will be calcium 2+? Don't write it down. So this would be this would just be for calcium. The calcium 2+ will be for calcium 2+. Did you say it's just AR? That is correct. It is just AR.
Or makes sense. So I was like, okay.
Okay, telling us that it's isoelectronic to AR. It's gonna have the same number of electrons as AR. That's it. Okay, you guys see that? So when we talked about tellurium, we did Te 2-, it's gonna be isoelectronic too.
Are we doing
Yeah. So Te normally is, I did this earlier, right? Get on the board. It's Kr. Okay.
Oh, yeah. Are we ready? Just like that?
What's that? Yeah, it's just the same. Then you have 4. So we have 2 electrons. Or we could just write it as Xe. Because if you add 2 electrons, 1, 2, right?
That's
Or the long way.
The longer way. Yeah.
Oh, okay.
That's right.
So, right.
Oh, it's that one. It's actually shorter. Because you can start that to the closest one to that. Add to that, and then look at it, and then forward.
Oh.
And KR is a long.
So do you guys see the difference?
Yeah.
Okay, now because it's isoelectronic to Xe, because it just relates. Okay. Are you guys with me?
Yeah.
Shrugging your shoulders, it doesn't mean anything to me. Okay. You're like, you're gonna make sure the tutor earns her money. That's.
Well, I don't know, it's like a different way, like, I feel like we used it in one way and then she explains it another. Yeah.
Okay, questions, concerns? Yeah, cool. Okay, so ionic compounds, we know that they're going to be ionic bonds, and they're going to be held together because of those opposites, right? So those 2 opposites that are attracted. Now, normally ionic bonds, they're going to form what we call a crystal lattice. Sure, yeah. So they're going to form a lattice like. Okay, it's going to form. So that sodium with chlorine, with sodium, chlorine, with sodium ion or chloride ion, sodium ion, chloride ion. So it's going to be alternating charges, and it's going to form this little lattice altogether. So this is how it's really interacting because it's based upon charge. So it's going to be surrounded by those positive charges that chlorine is, and then the sodium is going to be surrounded by the negative charges. Okay. So when we boil it, we heat it up so much that it's liquid, it's able to conduct electricity. It has those charges. As soon as the charges are free from each other, they're not interacting with each other, then they're able to conduct electricity, which causes it to be free. Okay, covalent bonds. Covalent bonds means that they're sharing electrons. Talked about this. Just it should be a refresher, right? So covalent materials don't conduct electricity or should not conduct electricity. You guys will find out this week or later next week that isn't necessarily true by all water. If the water is totally pure and it doesn't have any ions in it, then it should be able to conduct electricity. The painful water, right? It's able to conduct electricity. Yeah, so sugar to water, it's not. It's very evenly bonded. So that means that the electrons are being shared. They're not that plus and minus charge. They're being shared between two atoms. Okay, so this is what it looks like when they actually bond. So you basically, this represents the electron cloud event. So the electron will revolve and circle around both of these. Okay, so you guys want to gas plus in the middle. Okay, so because of that, you don't have those electrons. Okay, this is the Lewis structure. I'm going to hold off. This is not going to be on the exam. Okay, we're not going to do this part on the exam, but I wanted to talk to you about covalent bonds and non-covalent bonds. This it should be on the exam. You know, it may be a multiple choice question, but the Lewis structure is that again you're sharing electrons. So you want to try to set it up so that you have 8 electrons around. Right? So chlorine both have 7 valence electrons. Okay, and you guys, if you guys get your electron configuration, count 1, 2, 3, 4, 5, 6, 7. That's the number of electrons. So just counting the S and the P's, right? So fluorine has 7 valence electrons each. So when you put them together, they want to have 8 surrounding them. So they share a bond between the two. Waves that we represent sharing of a bond with all. Okay, just clear on that?
Yes.
Okay. So if we count, you guys come together, that's 2, 4, 6, 8 around this building. That's 2, 4, 6, 8 around this building. Okay. Each one has 7, but when they're covalently bonded, they're sharing electrons. And they're sharing, literally, they'll share a bond between 1 electron for each one is being given. Now, that's not going to always be the case. Not in every case will they give up 1 electron. Sometimes you'll have an atom that will give 2 electrons, and the other one will only give 1. Try to make this work out. Okay, so let me give you guys an example. Okay. Let's say we have okay. So okay, so we know that covalent bonds are formed between non-metals. So we know that this guy's got a form of covalent bond, right? Because these are all metals, okay? So they're going to be sharing electrons. So how many of this does nitrogen has 5 valence electrons. So that's 1, 2, 3, 4. Okay. Hydrogen has how many valence electrons? 1. Okay, we have 3 hydrogen, each one has 1. Added together, we have 8 valence electrons. Okay, so we have 8 electrons to work with. Okay, now there are a couple of rules that you want to keep in mind. One of those rules, very, very important rule, is that hydrogen will never be in the middle. It will never be a center atom. Okay, hydrogen can never be in the middle. Okay, it can only form 1 bond, so it will never be in the middle. So it can't form 2 attachments. It only have 1 attachment. Okay, so if that's the case, we know that nitrogen has to be in the middle. Okay, so hydrogen has 1 electron that it can donate. So we have 2 electrons over here. They form a bond. Bond. Okay, that's your Lewis dot structure. Okay, now the goal is to try to find it so that everybody's octet is reached. Okay, yes, so meaning that they all have 8 around it, except hydrogen only wants to have 2 around it, and helium only wants to have 2 around it. Okay, the other guys they're able to have 8 around it. Okay, when they're forming covalent bonds. So if I have something, you already got this.
So I have see that.
Everybody have it? Have your educated guess? Okay, I can erase this one already? Yeah. Okay, so let me give you guys a couple of other rules, just in general. So, the closer you are to being a noble gas, the more likely that you will not be in the middle. The further you are away from being a noble gas, so in this case, it's that, so the middle, right? So we have carbon. That has how many valence electrons?
4.
It has 4 valence electrons. So 1, 2, 3, 4. Oxygen has 6. 6. Okay, so we need to move electrons around. Now remember, electrons are movable, right? So we can move them around so that we can get 8 around everything, right? So. let's do this. That would be 6, right? Around both.
Yeah.
Okay. So if I move this set of electrons around both, that would give me still be 6 around this guy, right? So, but what if I do this? I have a other one. So in other words, I have C. Okay, what's that mean? Okay, this is like triple. Right. Okay, one line between it, that's a single bond. We have 2 lines between it, that'll be a double bond. We have 3 lines between it, that'll be a triple. Yeah, you can only do a triple bond.
When there's 2 like that,
What was that?
when it's 2 like that, only triple bonds.
Well, it's not always guaranteed if there's 2. It's just, the goal is to try to get 8 around, right? We have a total of how many electrons? We have 4 plus 6, right? That's a total of 10 electrons. So we have 10 electrons to work with. So that's 2, 4, 6, 8, 10. Okay, so you gotta shift them so that everybody has 8 around. Okay, if we look around it, that's 2, 4, 6, 8 around this carbon. We have 2, 4, 6, 8 around this carbon.
Oh.
You guys can't see that. I have to see if I can draw it on this board.
Okay. I understand.
Find another color. So this would be 2 here. This is 4. That's 6. That's 8 around the carbon.
Yeah.
Okay, and then around that. Okay. Yeah, see that? Yes. So the line represents 2 electrons. Okay. The line represents 2 electrons. Okay, you guys got that?
The line represents 2 electrons.
Okay. So let's say we had something like O2. O2. This is O2. Yeah. Then I have one more thing, and then it's that. O2.
Especially if you
O2 by itself. Just O2.
Quizzes and challenges.
Yes, everybody wants to have 8 around. And maybe a little rambunctious and throw an extra credit question. You guys don't need any extra credit, right?
Well, then I'll just go home after that.
Whenever finish.
I will finish.
Or you know.
You'll get a comment. You'll get a comment. I will finished.
You're stuck on what? Are you good?
I told you.
So you're trying So what would make you home that I'm not home?
Oh, no.
So it's two. Oh, no. Or no. Yeah, what about my phone?
What was that? Yeah.
You're still.
Okay, you guys ready?
I don't think you count.
Yeah.
Okay. So, how many valence electrons does oxygen have?
Six.
It has 6.
4.
1, 2, 3,
I
4,
don't think you count.
5. Okay, so that's a total of 12 electrons on the orbital. 12 electrons. We want to try to shift it around so that each has 8 that will be surrounded. Okay, so how are we going to do that?
And then the 2 with the lines are equal 2, right?
Each one.
Each line equals 2.
Yeah. So, okay, so if you always count the number of total electrons you have, right? So that's 2, 4, 6, 8, 10, 12.
I have a question. Does it matter how you, where you put the dots at, or you put
Why couldn't you just left it how it was?
How, because
I
that
just
would have
added 2 lines.
Because that was only 6.
been without 2 lines.
You could have put it on
Well, the
the
dots on the
side.
side.
Oh, you can put the dots.
Oh, you're saying,
No,
okay, look,
I
yeah,
think it was.
I can look it up on top.
They can be anywhere, dots.
Yeah. they can be- Yeah, I don't want to look. I like them to look pretty. You don't have much, but they gotta look pretty.
Big, one of those.
Oh, I was. I'm getting out of that thing. Took me a while. Okay, any questions? You guys kind of got it? Say no. Want to try one more? One more.
Other than the 2 years of the science.
Yeah, they're on the test.
Wait, so you can just do it, right?
Okay.
Okay,
Let's
Give me the easy one, then challenge.
I didn't take this.
That's,
I didn't take it. I just wanted to experiment.
We'll do the N2.
And then I did my bio
N2.
too.
I like your son.
I did.
N2.
Do we get an extra point if it looks pretty?
That's a good question.
Because it's N2.
Each line has 2 lines. Each line represents 2.
Yes, right.
What about if it's like, can it be like 3 elements in one?
Or we want
3 what?
3 elements.
Yes, yes, you can. That's what we're gonna do next.
Would you be 5 left?
It's the maximum elements that can be.
Oh, it can be a whole bunch.
I'm 3. How many, I mean, it's either 2.6, because I did it like this. Like,
Okay, you guys wanna try it? Five. Okay, so that's 5 plus 5, so you have 10 to work. Okay. So what can I do? The triple bond. So here,
does it matter?
here, bring these over. Over. So then. Eight, stay around here. That's 2, 4, 6, 8. Around here, that's 2, 4, 6, 8, 10. Okay, all checks out.
One last line.
With the double bond?
Yeah.
So if I did it with the double bond, then I have 1, 2, 3, 1, 2, 3, right? Isn't that? So that 5, that's 2, 4, 6, 7, 8. 2, 4, 5, 6, 7. Sorry, I can't count. I just skipped the whole number. And then so that's 1, 2, 3, 5, 7, right? So then that would be 7, right? Yeah, that's 8 around. Okay, so we know that this can't be the case.
Wait,
Yes, you see that?
so when it's 10,
10 is counting all of them, right?
Right.
So we counted all of the electrons. Right? So if we counted this, that would be 2, 4, 6, 8, 10. So we have to count for all 10 electrons, right? Okay, now we want 8 around each element.
yeah,
So,
that's what I was trying to say.
yeah, so here, you look at around that one, that's 2, 4, 6, 8 around this one. Okay, and then if we look around this one, that's 2, 4, 6, 8 around that.
So there is no other way that you could have done it. But when it's like equal, right?
What was that? What do you mean by
Like it's
So remember, you want to try to reach around 10. So you want to have 8 around each, right? Around each element.
but if it's not possible,
When it's not possible, then you want to try to get as close to 8 as you can. You're not going to worry about that right now. I'll fix this. If you happen to get that, you'll get a free for that one. So this is going to be extra credit on the test. I'm trying to set it up so you both have it, but it'll be extra credit. Okay. Any other questions? Okay. So this means that we have a center atom, right?
CO2?
CO2, right? So the one that is the furthest away from the noble gas is going to be the center atom. Okay. It's also going to be the one that has the weakest, what we call electronegativity.
Everything that's.
Okay, you guys want to give it a shot? Ready?
Yeah.
Okay, so who's gonna be in the middle? Okay. Carbon has how many valence electrons?
4.
Okay. Oxygen has how many valence electrons?
6.
Okay. That's what, 16? Okay, so what can I do to make it work so that everybody has to do that? Okay, so
Oh.
okay, so you guys happy?
Do you have to put 2 in the middle?
For it to be.
A double bond?
Yeah.
Yes. So that's 2, 4, 6, 8. What do you mean by 3 dots?
Like, another set of dots like the bottom of the.
Okay, so you're saying like this. Oh,
Yeah, why can't you do it like that?
and then how many surround carbon? Okay, that's 2, 4, because the line represents 2 electrons. So that would be only 4. That's 2, 4 around carbon. It wants to be stable. Carbon wants to be stable. It's a 4. It wants to be stable.
Hey, I thought carbon is 4 valence.
It has 4 valence electrons, but the whole purpose of you bonding
That's 8.
is so that you're surrounded by 8 electrons. Remember, you want to be like a mobile gas. Either you're going to be getting there by giving up electrons, taking electrons, or sharing electrons. If you're not doing it, why do it, right? It's like if it doesn't get you to stability, why do it? Goal is to try to be stable. So we know that this is good math. Okay, you guys see that? So if I counted the number of electrons around carbon, that's 3, 4, 6, 8 around carbon. Then here, that's 2, 4, 6, 8 around. Yeah. Same thing. Okay, we got 15 minutes. 50 minutes. 30 minutes. So we're gonna have to keep the lab till next week. So what we'll do next Monday, you guys will have a 2 for class. Okay, I'll have all the stuff out. Yeah, you guys are required from the exam or worried about the exam, one or the other. Okay, So I'm not gonna let you go early, but actually, we'll talk about exceptions. Exceptions. So there are a couple of exceptions to the Bootstrap structure. Okay, so one of the exceptions, one of the more common exceptions, is when you can't get paid out. Choose actually. So if we take a look at nitrogen monoxide. Nitrogen monoxide is a very radical gas. That's radical is because it has that one extra electron. Anytime that you add up to a total number of electrons that's odd number. So for instance, we have how many valence electrons does nitrogen have? And oxygen? 6. That adds up to 11. Now you can twist and turn and move and do whatever you want to do. You're never gonna form 8 and 9. Okay? Never. Keep trying. You know, I have to pay $1,000 for that. And you keep trying. And trying. You're never gonna get in a situation where you have 8 electrons around both the nitrogen and the oxygen because it's an odd number. So the rule is the one that is the most electronegative, which is typically the one that is closest to the noble gases, right, is going to reach its octet. The other one is fine. It's going to be one. So we're going to get 7 around nitrogen and we're going to get 8 around oxygen because oxygen is more important because it's more electronegative. Okay, so 1, 3, 4, 5, 6. Okay, so we want to try to get it so that nitrogen has at least 7. So what am I going to do? We want to get it so that nitrogen has at least 7 around it, right? So there's no way it's going to have 8 around it because it's an odd number. So anytime that you have an odd number, you know you're never going to reach everybody's. There's going to be one guy who doesn't reach its octet, right? So I'm going to move those electrons in there. So that's 2, 4, 6, 8, 10, 11. 11 electrons. So we counted for all the electrons. We have 2, 4, 6, 8 around oxygen. Two, 4, 6, 7 around nitrogen. Okay. You guys see that? Now, this again is an exception to the octet rule. Okay, so it's an exception to the octet rule. Okay, so if I have Okay. Nitrogen's gonna be in the middle. Nitrogen has how many valence electrons? Oxygen has how many valence electrons? Okay, so what am I gonna do? Two for each? Like that?
And the other,
This one?
yes.
Sure.
Yes.
Why are you saying that?
Okay. I'm gonna follow your instructions.
Oh, yeah, okay, then we'll go from there.
Okay, oxygen did reach like 10. How many? Okay, so this is an issue, right? Because you don't want to go over 8. You only want to get to 7, right? Or 8. You want to get to 8 if you get to 8. But if you can't get to 8, you don't want to go over 8, right? Because that means that you have to use an additional shell other than that. You don't want to do that.
Remove one.
Steal from nitrogen.
Yeah, remove one.
Take one of those off, right? So then that's 2, 4, 6, 8. Don't move this.
Oh, you could just take one.
2, 4, 6, 8 around oxygen. 2, 4, 6, 8 around oxygen.
Yeah.
2, 4, 6, 7 around nitrogen. Okay, so you never want to go over 8. Okay. So you guys did a good job so far, right? So you ready for some more exceptions?
Yeah. Subject, I need all these subjects.
Okay. You guys still writing so much. I get anxious and I just want to go in there.
No, I'm seeing this one.
Okay, our next one is called, it's called hypovalence. Hypovalency basically means that hypo meaning under, right? So here, you're not gonna reach your octet because that element doesn't like to have 8 around, it, right? So hypo for that. Another one is beryllium. It's a metal who doesn't believe it's a metal. Okay? Beryllium only likes to have 4 electrons around it. So beryllium has how many valence electrons? Okay, chlorine has how many valence electrons? Yes. That's a total of 14. Okay, so chlorine only form one bond, single bond, only form single bonds. Chlorine, 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 iodide, and bromide. All those guys are halogens. Only want to form a single bond. Sometimes they're forced typically if they're with another halogen. That's from. Okay, so this guy, beryllium, will only have 4 electrons on it, 2 and 4, and then 4 is around. Okay, so that's it. Okay. It's one of those elements that thinks it's not extra. Trying to figure out its character. Okay. Now, and the other thing is that fluorine only wants to form single bonds. So he's not going to try to form double bonds, triple bonds, or anything like that. So no, I don't do that. Right? Only single bonds. Okay. And fluorine is like the bullet. He sets the tempo for everything. But when he's with other elements, he controls.
She sounds mean.
So this is an example. Again, this is called hypovolem. Boron also is going to be hypovolemic. The only thing, boron only wants to have 3 around it. I mean, sorry, 6 around it. So it's cool with having so it's always going to want to have 6 electrons. Examples of hypovolemic boron. Okay. You guys ready for your next one?
Yeah.
Okay, so our next one is hyper. What do you think hyper means? Hyper. Okay, so hypervalency basically means that you have more, right? Now, if you are in period 3 and higher, you have the ability of being hypervalent. Okay, if you're in period 3 or higher, you have the ability of being hypervalent. Read that one more time. If you are in period 3 or higher, you have the abilities of being hypervalent. Okay, so sulfur. So you know that chlorine doesn't like to form double bonds. So it's going to put sulfur in the middle. Sulfur has 6 valence electrons. 1, 4, 5, 6. Chlorine has 7 valence electrons. 7. Okay. Okay. Now, you want to try to reach your octet, but if you have to, so Chlorine does a good job at forcing sulfur to do hypervalency. So typically, you're gonna have this happen when you're paired up with a halogen, because halogens are typically strong. They're gonna bully people around. Okay? And again, you can do hypervalency when can you do hypervalency?
So, the atom is
Nitrogen. Could I do hypervalency? Is it P3 or higher? Where's nitrogen located at? That's right, you can carry it too. So nitrogen can't. Definitely. So it's phosphorus can, arsenic can, antimony can. Okay. Let's see. Oxy, you guys remember oxygen acid? Oxygen ions, oxy acids. Right? You guys remember those? Occasionally, oxy acids and oxy and ions will also disobey the object. Okay, so, but it won't be with oxygen, because oxygen is to make sure that it has what it has, but it'll make sulfur and stuff move around. Okay, are you guys okay? Yes, got it?
Yes.
Okay, so I will see you guys. Okay, and I owe you guys a whole bunch of labs.
Yeah.
This one is I'm ready for it too. I need something fun.
Vegas or what?
It is.
I mean, this one like, not yet. I'm for sure.
I don't know.
I need to get rest.
Is it?
It's about right.
Should have.
Yeah.
The library, so when we get.
Yeah, you gotta go to the library.
We went to myself.
We should go to the library then legislation.
But I wasn't.
And then she asks you your name.
We can just start it.
I mean, I can leave yours.
I got the notebook.
Okay.
I did too, so did she.
I let her first.
I got it.
Oh,
Yeah, and I like how the papers don't bleed through if you use. Oh, I
Yeah,
know,
it's
very
really
thick. I know it.
Dude, I know. She goes like at 12:30, no? Or like
Yeah, well, we were
there. Well, what's the 12:30 that she was?
She's a little. Because I'm gonna be so cool, just like, we'll do it and we'll go like, see what we do. That doesn't show us. But we can see like. What answers you got first.
Oh, yeah, I loved it today.
But we can see, we don't have homework, because we do it.
So I kept checking back there.
It's how it's.
Because with the exam, like, I feel like trying to see that